Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences BioScience Talks, which is a forum for integrating the life sciences. On the second Wednesday of each month, and sometimes in between, we discuss the latest bioscience publications. And as a reminder, if you'd like to read more, point your browser to academic.oup.com/bioscience. For today's episode, I'm joined by Dr. Steward Pickett, who's an ecologist at the Cary Institute of Ecosystem Studies in Millbrook, New York. He and I chatted about his recent BioScience article about the long-running Baltimore Ecosystem Study, as well as some of its theoretical underpinnings. And with no further ado, let's go to the interview. All right, Dr. Pickett, thank you very much for joining me today.
Thank you for having me.
Okay, let's start with a little bit of talk about urban ecology generally, which may not necessarily sync with all of our listeners' conceptions of ecology as being something that particularly would happen out in the wilderness or something like that. What are the aims of the field, and why do we study it in particular?
Urban ecology is, in fact, in the history of ecology as a field, it's an unusual specialty. It's one that's relatively recent. But I think that ecologists began to realize that if we didn't study urban areas, we were leaving aside a big part of the earth, a big part of the kinds of places that we really needed to know about. And in part, that's because there was a suspicion that urban areas would have a very different kind of ecology than those wild places or rural places or maybe more lightly managed places that ecologists have been studying. So we really began to explore cities as places that contained interesting ecological habitats and which contained biodiversity and which presented opportunities for different kinds of evolutionary responses and adaptations of organisms, for example.
Okay, and let's talk about the Baltimore Ecosystem Study in particular. I'm really interested in sort of, how the idea for it was originally formed, and when, of course, and, what kind of things led to that study area in particular.
We started the Baltimore Ecosystem Study because of some earlier work that I had been involved in with a number of people in the New York City area. We had looked at forests from the Bronx out into the suburban areas and then the countryside on the same kind of geology. And that was our start in urban ecology. That was my start in urban ecology. And from that grew the interest to really understand not just how the city or the suburbs or the countryside affected ecosystems, affected forests, but how those different areas, the city itself, suburbs themselves, and the countryside were particular kinds of ecosystems. And we started the study in Baltimore because it provided a really good opportunity, because of some other work that had been done there by social scientists. It provided a really good opportunity to think of an entire city, an entire metropolitan area, as an ecosystem. And that's a really different thing than studying the ecosystems, the green spaces, the blue spaces that are embedded in cities and suburbs.
Okay, and this study was begun in particular around about 1997?
That's right. It began in 1997. It was funded by the National Science Foundation, and there were two urban long-term ecological research sites, as they are called, which were started in that year, and the other one was in Phoenix, Arizona, metropolitan Phoenix, called the Central Arizona Phoenix Project.
Okay, and I suspect we're going to be talking, obviously a fair amount about theory as it's the focus of the article, but, and this may get into that a little bit, but, what kinds of data, were you initially collecting? It's one thing to study an ecosystem, but what does that amount to in sort of practical terms? What sort of sensors are used? Where are they located? And how are those decisions made?
The sensors that we use range in a variety of kinds of uses. We have studies of watersheds and streams, and so there are sondes in the streams, there are gauging stations, there are automated water samplers at the various stations along the major stream that we study. But we also have meteorological stations that are scattered throughout the city. We have had an amazing network of rain gauges that really show the heterogeneity of rainfall throughout the city. But we also do studies that involve human information about what people think about their neighborhoods, what their bases for decisions are, what their lifestyle categories are. So there's all kinds of data that we collect, including some sort of classical studies in forests and old fields, but in our case, the old fields are vacant lots, which Baltimore, of course, has an abundance of. So it's a whole range of things, ranging from social, demographic information to soils, soil biogeochemistry, stream biogeochemistry, and biodiversity of plants and animals, for example.
Okay, and so let's move to our, what will probably be a large part of our focus today, which is, the idea of theory and how it is incorporated in this sort of ecological study. What's the role of theory? You've mentioned, a number of pieces of data that would be collected over the years. Is theory sort of the methodology by which all of that's put together into something that, for lack of a better word, means something, or what kind of role does it play?
Theory does a couple of things in urban ecology. One, like you say, it's a tool for integrating all of these different areas that the specific data are collected in. So without theory, we're sort of left with the social data of this type, the stream data of that type, and so on. But the theory encourages us to bring those together. It gives us a framework to integrate the different kinds of data that we use.
Okay, and what were sort of the underlying theories when the project was initiated, and how did those change, perhaps over the early years?
Well, we started out with some pretty familiar theories in ecology, and they are so familiar actually that people often don't even think about them as theories. But the idea of a watershed really points to a larger theoretical area, a theory in and of itself, that considers how water moves through landscapes, both out on the surface and below ground, how that movement interacts with the substrates, interacts with soils, interacts with the above ground structures, the vegetation, the buildings, the pavements, and so on. So there's a real need to think about watersheds as this integrative realm, and theory of watersheds helps us to do that. But we also used some theories from social science, which I think could be broadly called socio-spatial differentiation, that talks about how different social structures come to exist, how they interact with each other, and how they change. But what we did, the integrative step that we did in the Baltimore Ecosystem Study, was to relate those social theories about spatial heterogeneity of the social demographic realm with the heterogeneity of our watersheds, with the heterogeneity of the vegetation throughout the Baltimore metropolitan area, and with the heterogeneity of the soils. So those are two kinds of basic theories that we started with. But as we developed as a study with more experience interacting across disciplines and gathering more data on the various realms of study that we were doing, we found that we needed theories that were sort of more comprehensive and didn't treat things as separate sorts of realms, but how could we theorize the metropolitan area? How could we theorize the city as a whole? And so that really required us to develop new kinds of hybrid approaches to urban ecosystems.
Okay, and before we get into those hybrid systems, just taking a step back, and looking at, the way that the social realm, is integrated into, a study of an ecosystem. Can you give us an example of what that might look like in practical terms? Is that things like street trees where they might exist or not exist, for example? What are kind of the things that feed into that broader understanding of an ecosystem in this context?
Well, street trees are, of course, a good example of how people interact with the biophysical environment, because people make decisions both as individual householders, but also as parts of city agencies, and different city departments think about trees differently. So one of the first things we did was to try to categorize where the trees and the vegetation in general was in the city, what kinds of properties the vegetation, the woody vegetation, was on, and how people managed it, how they made decisions about the trees in front of their house, or the trees in the parks, or in fact, how people thought about the trees that were just volunteers in the hedgerows that were kind of neglected between properties, or the trees that came up in vacant lots. How do people think about them? How do they see them as either benefits or hazards in the city? And we did some of the work that I find most intriguing was the work that we did to relate canopy cover, tree canopy cover, with the crime statistics. And very often in cities, people informally say, well, trees are associated with crime because bad guys can hide behind them, or they can stash things in the vegetation. And we found in a survey of the vegetation, the forest vegetation in Baltimore, the trees in Baltimore, and crime statistics, and in fact the opposite was the case, that more trees were associated with less crime. And the only exceptions to that were in some old industrial neighborhoods where there weren't very many people present, so there weren't eyes on the street, and the trees that were there were not actually something that was being managed. So there were some interesting rules and some telling exceptions. And that's an example of a new kind of theoretical melding of social information with biophysical information.
Oh, so that's an interesting finding. So, you could have a case where you had this incorrect bias against tree cover when in fact it's negatively correlated with crime outcomes.
That's right. So this is sort of a theoretical expansion that gives people a new way to think about the trees in their city. And we're not saying that there won't be problems with trees, but it allows us to say, hey, it's not always going to be negative.
Right. And so, then how do those sorts of ideas, of incorporating everything together kind of expand out into the hybrid theories that were later developed?
Well, one of the things that we discovered early on is that the way that people classify urban lands is a very sort of fragmented approach. You can go into the system and you can find, all right, well, where are the built areas? Where's the pavement? Where are the forested areas? Where is the ag in these areas? And so you classify things as though you were looking at sort of the continental scale, and you wanted to know where all the farms were and where all the production forests were and where all the human habitations were. It's a very sort of separated view of the world. Nature versus culture, nature versus technology. And when we started studying in Baltimore, we said, well, we do need a way to classify the lands, the covers, but the things that the standard land cover classifications, land use and land cover classifications that were available were really not helpful to us. They were too coarse, and they saw the city not as a system, but as a collection of disparate parts. And so we came up with a new land cover classification that said the city is made up of patches, but each patch can contain built, surface, and vegetation. And the point of the classification was to say how much of each of those three kinds of major covers could exist in each patch. Not that the city was made up of residential patches or forest patches or old ag patches or things like that, but think about all of these three things together as potentially being parts of all the land covers, all the covers in the city. And that was a really radically new way to think about the city, and one that really helped us to integrate our views of Baltimore and how data could be compared.
And, in terms of research finding outcomes, how does the result of looking at things, through that sort of more complex view of patches differ from what might have been I would imagine, kind of blockier, almost more pixelated approach that you would have had using historical methodologies? What can you learn doing it that way versus what you might have learned, using legacy techniques?
Well, the kinds of things that we've learned is that the various kinds of controls on ecological processes, the various kinds of controls on social processes are actually a mixture of the biological and the social. And so that's a very different sort of way to model how the city works. It's not just driven by technology. It's not just driven by density of people. It's not just driven by how much vegetation has been reestablished or has been removed or replaced by managed vegetation. It's a mixture of those things. And those kinds of mixtures, having those mixtures in mind, is a way to help you do two practical things. One, as Baltimore moved into its sustainability plan, which was adopted in 2009, it allowed them to think about all parts of the city in terms of how they might contribute to sustainability, not just to look at the green spaces and say, sustainability emerges only from those green spaces, but how does sustainability emerge from the mixtures of the built, the surface, the buildings, and the vegetation, for example? So that's a nice, it expands the scope of sustainability efforts in Baltimore. And then the other way that it's been useful is for urban designers and landscape architects and architects to think about planning in a different way, to think more fine scale about how you structure different neighborhoods, what you do in blocks where there's a lot of vacancy that needs to be replaced, what you do in new developments that can advance the sustainability of the whole region, not just make a pretty landscape for an industrial park or a new headquarters building or something like that. It really allows people to think in a more integrated way about all the things that are going on in the city when they make changes.
Okay, and thinking of an example of that, one of the ones that springs to mind from your article was this idea of opening up sewerage to improve nitrogen handling in riparian systems. Is that the kind of thing that this perspective gives you that you might not have previously understood if you were looking at things, in a sort of an isolated way?
That is actually one of the kinds of cases that we worked with in Baltimore to expand the thinking of control of nitrate loading to streams, the reduction of nitrate pollution in streams, to expand the thinking of that from the riparian zones out into the rest of the city, because the riparian zones are not functioning quite in the way that they would in rural situations, so you can't depend on them to do the work of nitrate reduction. So what that means is that you have to expand your scope outward and think about the uplands as a part of your nutrient processing, your sediment processing system. And so you work with green infrastructure, you work with the parks, you work with street trees, you work with street sweeping even, you work with removal of asphalt in old schoolyards where it's not needed. You do new kinds of paving, the pervious paving, in places where you can manage that. And so you can really expand that nitrate management throughout the city in this mixture of land covers that we have come to understand.
And if you're not looking at land covers in sort of that, more complex and nuanced way, the old tendency might be to, view, say, a densely populated residential area as simply impervious and not something, that's an opportunity potentially to, help meet sustainability goals.
That's right. So how we think about things, and the city is very good about thinking about this. We're in conversation with them a lot. So really, there's a lot of work now that is looking at how to improve the stormwater management throughout the city in specific neighborhoods, including some that you might not have looked at under the old regime of saying, well, okay, it's built, it's dense, it's highly paved, there's nothing to be done here. And there are things that you can do even in those very dense, old, highly impervious neighborhoods.
Now, I'm kind of curious about this because I always tend to look at things, or I'm eager to look at things and research in the sense of its application. What's it like working with, Baltimore and its various governance structures? What kind of role do you play as ecologists in informing the management actions that they might take?
Well, one of the reasons we went to Baltimore to establish this project is that there had been about a decade of work, social environmental work that had been done with a not-for-profit and some city agencies looking at how neighborhood quality of life might be improved by some environmental additions to those neighborhoods. So there was a habit in Baltimore of thinking about environment as being a tool that they could use for neighborhood benefit. And when we established the Baltimore Ecosystem Study, we very much, the reason we went to Baltimore to do this is that there was this sort of culture there, and we could tap into a functioning network that brought environment into the operations of quality of life in the city. And so we started out right away in being members of a network, not as deliverers of information, not in that sort of old-fashioned delivery mode of science application, but as members of a community involved in conversations. And so sometimes we would learn from what the city managers and neighborhood associations were doing and say, hey, this is really cool. We can measure some things here that will help us to understand the ecology of the city, but also perhaps help them understand the effectiveness of the various things that they were doing. So we would it was a matter of being in very, very frequent conversation, just asking people, what are you doing? What are you learning? What are your needs? What are your concerns? Not that we could solve every problem that came up in those conversations, but by having those conversations, we knew where the opportunities were to make science connect better with the city. And I think that's been our success with operating in Baltimore as an applied activity.
Yeah, that's interesting. I think that in particular also sounds like a useful model to be applied elsewhere, be it in this field or others, of having scientists and researchers integrated into the management in a way that kind of allows you to be participants in the process rather than sort of outside purveyors of wisdom and information and things like that.
That's absolutely right. One of the worst things that we can do as scientists is come striding down the hill with a couple of stone tablets.
Right. It doesn't seem to work very well. What's next, broadly speaking, for this sort of research and for the Baltimore Ecosystem Study in particular? Are there new concepts on the rise that are helping to inform the work that you're doing?
One of the things that the theoretical horizon in the Baltimore Ecosystem Study has exposed to us is some theoretical thinking that is very useful in places way, way beyond Baltimore. There's some new conceptual tools that we're working on. One is called the Continuum of Urbanity, which is a crazy name, I know, but what it emphasizes is the connectivities amongst cities as well as within cities and all kinds of human settlement areas, how they interact with resource air supplying areas, how they interact with lands that seem to be rural or wild. So seeing cities as part of broader regional and even global networks, ecologically, socially, technologically, and in terms of governance, that's a really powerful new way to think. And figuring out how Baltimore fits into that, how those larger connections explain what's going on in Baltimore, and how some of the things that we've learned in Baltimore can inform that theoretical nexus is really, really useful. But in a perhaps more practical sense, the Baltimore Ecosystem Study, there are many people in the study who are saying, what do we do? What's the next act? And the next act is to become more integrated in the processes of environmental decision making, from households through the NGOs, through the various agencies at the city and state level and the various jurisdictions that are part of metropolitan Baltimore. And the goal is to formulate something called a Baltimore Ecosystem Alliance. So something that really has science as one of its big tools, but that is engaged in identifying problems that science can be relevant to, identifying problems from various perspectives, not just having research driven by the desire to advance science itself or even to advance the theory of science. But we're pretty sure that kind of embeddedness will in fact have positive outcomes for the science itself.
And who sets up such an alliance? Is this something that you initiate out of your labs, or is this something that comes into being through a collaboration of a large group of people? Who are the players in that sort of operation?
The players in that operation are a whole host of folks, and there have been some conversations over the last year or so that involve not only scientists, and the scientists involved are explicitly trying not to say, hey, we're going to be the leaders in this, but we want to be a part of this conversation. And it involves people like there are environmental lawyers, there are leaders of various faith organizations, there are the leaders and staff of some of the not-for-profits that deal with environmental quality and water quality in particular in Baltimore. There are people from the city agencies, the Department of Public Works, the Department of Recreation and Parks, the city forester, and so on. So it's a big round table. It's a big group that says we want to help Baltimore be a better place. We want to help science be a part of that. And so it's a big community.
And in general, either the alliance in particular, or your efforts in other ways as well, how applicable and generalizable is this sort of methodology to other urban areas? Can you take the models that you're developing for Baltimore and apply them to other cities? And is that kind of thing being done?
Well, one of the advantages of theory is that it resides on a level of generalization or generality that invites you to make those comparisons. And we are in fact trying out those comparisons, and we are involved in various sorts of studies and groups of folks that are doing that. There's the research network that deals with ecology of extreme events that has a network of 9 cities throughout the Americas, and Baltimore is one of them. And so that's a vehicle to share the ways of thinking and the approaches that we've developed. We have a lot of comparative work, say with China, and you might just instantly think that, well, what does a post-industrial city like Baltimore have to do with the explosive urbanization in China? And that's an open question. It's a question that we're exploring, and we are looking with colleagues in China at how the insights that we're developing in Baltimore apply in their cities, or some of the the insights that we have about environmental quality in a city as an integrated function, how that might apply to these new cities in these newly developing cities or rapidly expanding cities in China. And we're working with some of the cities, some of the larger cities actually, that are really eager to apply these insights. And so that's been a really positive kind of outcome for expanding beyond Baltimore. And it works.
That's fascinating. And it's been very nice for the past 30 minutes not to speak of global pandemic. But I think we're stuck asking that question, for the foreseeable future on these podcasts. How has COVID-19 and the various, mitigation and suppression efforts affected your work? Whether that be in data collection or your ability to collaborate with international partners, et cetera. What's the experience been like so far?
Well, the experience has been that the field work really is on hold because you can't have people out in a city socially distanced, meaning that you must go out in teams. And, that's good practice in any kind of research area. Out in the wilderness, you don't want to be the only person out there. So that's really slowed us down, but we're confident that these long-term data sets will pick back up and will continue to be of value. The sort of interactions, especially with international colleagues, the colleagues in China, of course, they went into kind of a panic mode that's similar to the panic mode that we're in now. But we were able to maintain using the electronic platforms, and I won't name any, but there are a number of them that you can use, and they worked just fine. We're finding that a lot of our project meetings, for various reasons, are adequately served by the online video media, but in part that's because we've worked with each other so long and so well before this hit. So there's social capital, if you will, that we're able to draw on that is not is not really damaged by the limitations of video conferencing.
Well, that's very good news. So it's a situation in which you can kind of rely on already formed relationships rather than having to forge new ones over various electronic platforms that shall not be named, which might be more difficult.
I suspect that would be quite difficult. So we're very fortunate to already have good networks in place.
Well, that's a rare bit of good news, and I think we'll certainly look forward to the resumption of that field work as soon as is practicable. Dr. Pickett, thank you very much for joining me today.
Thank you.
And that concludes this episode of BioScience Talks. Just a reminder, the journal BioScience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.